Good morning, everyone. Thank you, Bill. Thank you, Eddie. Thank you, Carla, the rest of the committee, and all of you for joining us this morning. For our first session on open source for local government, emergency management response, and climate risk, we have 4 great presenters today whose applications have value inherent not only in their applications and the data services they're providing, but also in the underlying technology and the technical approach that they've used to create these applications, which hopefully have some relevance or value to your unique business applications and how you're trying to understand and solve any variety of problems that we have in the world today. So with that, I will introduce Aaron, Mike, Laura, and Karen with their bios, and we'll start marching through the presentations, and we'll have probably 7 minutes or so of Q&A at the end and a panel discussion. Starting with Aaron. Aaron Myers is Group Lead for Geoinformatics Engineering Group in the Geospatial Science and Human Security Division at Oak Ridge National Lab. Mr. Myers leads researchers and development teams to push forward geospatial architecture and novel data processing workflows to solve global scale challenges in energy security and national security. He is also the principal investigator for the Environment for Analysis of Geolocated Energy Information, or EAGLE-ITM, for the Department of Energy's Office of Cybersecurity, Energy Security, and Emergency Response, which is a situational awareness platform for monitoring the energy sector. Aaron has also been an integral part of developing our geospatial compute strategy and supporting the development of multiple geospatial web applications. So thank you, Aaron. Laura Schuch, Dr. Laura Schuch with Cleveland Metroparks. Dr. Schuch is the GIS Manager and Drone Program Coordinator for Cleveland Metroparks in Cleveland, Ohio. Prior to joining CMP in April of 2022, she worked in the private, public, academic, and nonprofit sectors. Outside of working at the Park District, Dr. Schuch continues sharing her love of geospatial data through teaching in the Masters in GIS program at Kent State University in Kent, Ohio. So thank you, Laura. Mike Rogers, co-founder of CRG Plans. Michael left the Army as a captain after 9 years of service and multiple combat deployments with assignments including the 82nd Airborne, 75th Ranger Regiment, and Princeton University's ROTC program. He is a graduate of the United States Military Academy at West Point. Critical Response Group is the nation's leading provider of critical incident mapping data, a mapping solution used to enhance command and control efforts during an emergency. This vital data is integrated into over 50+ public safety platforms and is made available and hosted using open source technologies. Thank you, Mike. Thanks for your service. And Karen Townsend with Sea Island Software. Karen Townsend is president of Sea Island Software, a Richmond, Virginia-based company specializing in hurricane decision support. Her work with GIS began at Clemson University's forest applications in the mid-90s, then transitioned to weather and emergency management in 2001 when she joined her meteorologist father-in-law in the ongoing development of HurEvac. And with that, we will introduce Aaron. Thank you very much.
There we go. All right, so I'm Aaron Myers. I'm the Group Leader of Geoinformatics Engineering. So we do a lot of work around emergency response and situational awareness to reduce the latency from data generation to delivery. We create a lot of unique data sets, and we create analytic capabilities that support our mission analysts. Throughout all of these research goals, we integrate very heavily with different open source softwares. One of our leading capabilities in this area is our EAGLE-I platform, which is DOE's situational awareness platform for the energy sector. We currently cover about 93% of utility customers within the U.S. In 2017, the EAGLE-I program came back to Oak Ridge, where it had kind of originated, and we did a full assessment of how we're going to make this platform, this capability, sustainable for our federal response. And from that, we completely rebuilt the architecture from commercial off-the-shelf capabilities using open source technologies, Postgres databases, GeoServer, lots of different things. We want to enable this capability not to just be a standalone platform. We want to enable services. We want to enable existing situational awareness platforms through WMS services, using GeoServer, WFS services, also just using open standards such as GeoJSON. So that permeates all of the concepts that we do when we're building web applications such as GeoServer. In conjunction with that, supported by DOE's Office of Electricity, is a capability called ODIN, which is the Outage Data Initiative nationwide. They're taking a slightly different approach to electric customer data, where they're trying to create the standard for which this data can be exchanged throughout the community. Everyone consumes and pushes out the data in different formats. So they're actually working with the outage management system vendors to implement this standard within their software. So then capabilities such as Eagle Eye can then collect it using a standard format and make it more maintainable moving forward. We've also open sourced the Eagle Eye data. So we have historic outage data going back to 2014. And each year, so this year in 2023 or 2024, we released all of last year's data. So annually we'll be releasing this data. This data has already been used to look at environmental justice questions, trying to address capabilities from the Grid Deployment Office. So it's a really robust data set that can be used to look at climate questions and to try to understand kind of different impacts on grid resilience. We have a publication in Nature Scientific Data that explains our methodologies and how we collect the data, how we aggregate the data, and some of the challenges that are inherent in that data collection. We've also, because it doesn't exist, developed an open source utility customer data set. For every utility in the United States, we can say for that utility that covers this county, we can give you an estimate, a modeled estimate of how many customers, not people, that utility covers. And we can even eventually in the future break that down into residential, industrial, commercial. But right now we're just giving out the totals. But again, that'll help you get to that, get you some granularity within that utility data set that's not provided anywhere else at a national scale. Also, for emergency response, we need to create open energy data sets. So Oak Ridge supports the creation of multiple high-field data layers, but most specifically for the energy sector. So looking at transmission lines, substations, power plants, electric service territories, lots of different things that are also related to that kind of response, hospitals, nursing homes, and things like that. So we actually create the data. We create it all from open sources and using open source methods such that we can then share that back through the high-field programs. And so this helps us to create good attribution. And then through our work with Eagle Eye and other emergency response efforts, this allows us to actually get user feedback and understand how these data sets can be better used to answer the questions that come up in a real response mission. And through our work with FEMA, we actually created the USA Structures data set, which can be downloaded from FEMA's Geo platform. Again, completely open sourced. We cover all the U.S. and its territories. This information has been used extensively. It's been briefed up to the White House. So really great information about all the structures in the U.S. Of certain sizes. We even attribute them with expected facility types, usages, heights. So we're trying to add more and more metadata to this information. And to build upon this capability of our structures data set, we're actually creating a capability that's called Global Building Intelligence. So not only for the U.S., but we want to do this for the world. So not only do we want to tell you that there is a structure and what type of use it might be, but actually what is that building made of? What else can we tell them? What's the occupancy curve? When do we expect people to be within that building? And so trying to use different statistical analytic methods to take that information, feed that back into USA Structures and other open source buildings data sets to create a more robust understanding of the built environment around the globe. And finally, so reducing that time from data to decision making. So we've created an open source platform that we call Mapster, which is a play on the old music sharing capability called Napster. We have a very robust drone program at Oak Ridge that is tied in with the Eagle Eye program. And so we're creating grab-and-go GeoInc capabilities that can be deployed in emergency response scenarios. And one of the big challenges that we faced was how do we get that imagery from the laptop back to a centralized location, because in emergency response, a responder kind of doesn't care about that. So Mapster helps us do that. So it automatically collects data in the field, and it sends that back to the checkpoints, and into an imagery store that we then have at Oak Ridge that we can then run high-performance computing capabilities. Not only do we want to use our drone capabilities, but we want to support other existing drone capabilities. So partnering with other utilities, with other agencies that have a drone capability to have them push data into our Mapster, and then they can take advantage of the analytics that allow us to do things like utility pole damage detection or debris estimation. Combining that with our USA Structures data set, we can then do actual building damage assessment. And then also bringing in other even higherly remotely sensed information from satellites. We have a ground station at the lab. So feeding all of this into a centralized capability, all built using open source technologies and capabilities that create really unique analytic pipelines that feed back into systems such as Eagle Eye or even into other partner agencies, emergency operations capabilities that can allow them to more quickly get information, understand what's happening on the ground more rapidly. Thank you.
Great stuff, Aaron. Thank you. Next up, we have Dr. Laura Schuch with Cleveland Metroparks.
Awesome. Good morning. I am so happy to be here to get to share what we're doing at the Cleveland Metroparks to ensure that all of our staff and the public have access to geospatial data through our open source stack and our map store integration. Okay, so you already know a little bit about me. I'll just talk about the picture there. That is actually taken from one of our drone pilots. We currently have about 6 pilots and then outside of our police department, and our police department actually has 3 as well. So this is one of our newest park additions, and you can see Lake Erie to the right, and it's looking at the Cleveland skyline to the west. Just a little bit about the Cleveland Metroparks. We are a political subdivision of the state of Ohio. We have 18 park reservations, 9 golf courses, 5 nature centers, and we own and operate the Cleveland Metroparks Zoo. We currently have over 25,000 acres, but that number is constantly growing. And we have acreage in 49 different communities and 6 surrounding counties, and we actually have 4 of our reservations share property with the Cuyahoga Valley National Park. And we currently have 325 miles of trails, and you'll see that number is actually a little bit incorrect in one of my videos here. And we have over 20,000 annual nature programs. So we do a lot. We currently have about 1,500 employees. And now a little bit about the GIS program, because that's where I come into play. So we have a team of 4 people that kind of manage all of our park-wide layers and all of our resources. But we currently have about 40 desktop GIS users in the park district. So GIS is a major part of what we do, and we are completely open source. So we develop the resources to enhance any of the park district initiatives. And as I said, we're acquiring property, we're changing trails, we're constantly making changes. So this is very dynamic data, and having access to that most recent data is incredibly important. On the right, you see a picture of a utility like GPS and a hydrant. One of the things we're doing is mapping out all of our utilities. Okay, so what you see, this is the Map Store landing page. And this is actually, I'm not logged in. If I were logged in, you would see a lot more maps. We rolled out Map Store last year, spring of 2023, and on the left you're going to see a list of, these are just a sample of the different types of maps that we have available to staff. Those in black are what I would call thematic maps. They are designed for a specific purpose for our staff that do not want to get too far into the weeds with GIS. They're just going to go to that and get what they need out of it. And those that are in blue were designed to be base maps for particular users. So these are going to be staff that want to create their own map based on this base map, because one of the beautiful things about Map Store is that you can save it and you can really create it your own. You can add your own annotations and save them. You can put in whatever layers you want, and it becomes your own GIS. I'm going to start each slide is going to have a little bit of a video, so I'm going to share that in a second. But we have wanted to create a lot of customizations to Map Store, and that's the beauty of Map Store, is that you can customize it to make it what you want. One of the things we found before we had Map Store, we had this kind of old, crusty, hard-coded web mapping platform. Unfortunately, a lot of the staff loved it, but it was old, and we couldn't keep it updated. Like, updating it was a major process. It was, just lots of code. So that's where Map Store came into play, because it's integrated integrated with all of our, with GeoServer, with our database, with QGIS. It's fantastic. So we wanted to take the best of that old crusty platform and bring that into MapStore. So one of the things they really wanted was this customized PDF for our print templates. That became very, very important. And then we also have a catalog of the map layers that integrates with QGIS for our QGIS users so they can actually just kind of go back and forth seamlessly. And what I'm going to show here is a customized feature info response. So it's going to have a side panel with information about the map. This particular map is actually, it's called Justice 40 initiative from the Biden administration, and it was an effort to identify disadvantaged census tracts based on 34 different indicators in 8 different categories. The blue census tracts are those that are considered disadvantaged, and as you could see, a lot of those are within our park boundaries. I zoomed into the area near the zoo to just kind of show that side panel, not only are you getting the indicators for that particular census tract, you're actually getting an understanding of the methodology that was used to create those indicators so that our staff, not only can they see the data, but they understand what they're looking at. Then we had some customizations that required some assistance from GeoSolutions because we do not have a developer on staff. So sometimes we need a little bit of help, and it's been a great partnership. So one of those things, our IT department really wanted for us to integrate LDAP and Active Directory so that we have a single sign-on for all of our users. So from a cybersecurity perspective, that was their focus. For us, it made it a lot easier for people to get into the application. So that was actually kind of a win-win. And then we also wanted to create custom map scales with Geo Web Cache. So what that means is we have a lot of engineers and architects that have very specific scales that they like to see. So we had to kind of work with GeoSolutions so that we could show them those very specific scales. And what I'm showing in this video is we showed this disadvantaged census tract map to our mobile outreach team. And their goal is to reach out to those disadvantaged communities and specifically schools. So they wanted to know what schools are within those census tracts that they're already going to. And what MapStore has is the ability to view an attribute table and superior filtering skills. It is so easy to filter these fields, so you don't have to open up another pop-up and enter in like a spatial query. You're actually just filtering right there in the map, which is great for people that are not familiar with GIS. MapStore also functions as a data repository because it is connected to our database. So what I'm showing here is this was specific for our real estate department who often look at some of our old land maps. So these are the first maps of our park district, kind of back 100 years ago. And so we pulled up the index, and from there you can actually, this is a web mapping service, you can pull up each one of those maps. And it's actually really, really cool to see. It's super fast. To load, which I absolutely love. So do they, because anytime a user, it's a little bit too long, you hear about it. So we're kind of pulling in these two. These are from Rocky River. This was our first reservation. And you can see as we zoom in, I'm also going to adjust the transparency, which is really, really easy to do because it's just a slider bar right there under the layer. Absolutely love it. Dashboards, we're just kind of at the tip of the iceberg with the dashboards. This particular one is for our trails data. And I threw up that number, 325 miles of trail. You can see on this dashboard that we actually are closer to 330 miles. So this is connected to our database. It's dynamic data. This is one of the most requested things that we get from our marketing department, from our CEO. Where are our trails and what kind of trails do we have in each reservation? Next, we have GeoStories. So this is another part of the MapStore interface. And what GeoStories are is they're a narrative that associates with your data. I'm going to show you one for our capital projects map. So this was about a year ago, so it's a little bit out of date. But we needed to share this with the public. We needed to share it with our stakeholders and our partners. They wanted to know what capital projects are you working on. So we created a GeoStory so they can not only work with the data interactively, they can click on the carousel at the bottom, see that image. They're linked to other PDFs, videos, anything you want can be linked in there. MapStore also works on a mobile device, and I figured this out because I was out in the field and I needed to know where I was at, so I actually said, hey, can I pull up MapStore? And it was actually really, really useful. It was very helpful. Here I'm kind of showing kind of my location at the time, and it'll actually give you a distance if you click on another point. So it's also very useful. You can access all of that data that's associated with the layer. All right, drone program. As I said, we have quite a few drone pilots. And we have a lot of requests coming. Now that we have more pilots, we have the ability to get it done. One of the challenges we have is people don't know where we have flown. So we decided to create a drone flight inventory map so that our staff can look and see. They can actually see the restricted areas. I'm going to turn them on because we have 3 airports in our region for which we have to get FAA authorizations to fly. And it's kind of a lot of our land. So not only can they see that, so they know if it's going to take a little bit of extra time for us to get that flight in. This I'm showing here is that we have created special searches for our staff because with that much land and that many amenities, that many facilities, it can get a little bit cumbersome to search. So we created a specialized version for them to do that. And there they can look at the flights. So in the future, what we would love to do is bring that drone data into the 3D component of MapStore. So what I'm showing here, this was created in WebODM, which is actually created with the Cleveland Metroparks. And we have a project area called Garfield Pond. We're doing a pond reconstruction, facilities. We're building an activity center. So what we would love to do is bring these data into the 3D component. Additional applications for 3D data, I would love to see our utility data in an augmented reality format so that anytime someone needs to go and dig into the ground, they know if they're going to hit something. And we also have a lot more planned updates. I won't go through all of these, but these are more customizations that we are going to do. Thank you.
Thank you, Laura. Excellent stuff. And I will mention if anybody's interested in learning more, you can hunt either the panelists down or some of us are set up at the GeoSolutions table so we can talk more about MapStore. We have an expert in the house. Next up is Mike Rogers with Critical Response Group.
Good morning. Is this the PowerPoint? Great. Good morning, everyone. Appreciate the opportunity to be here this morning. As Ryan said, my name is Mike Rogers. I'm the CEO of a company called Critical Response Group. My background, briefly because it's important as to why I'm standing here today, is I come from a long family of public safety professionals. My dad's a 5th generation cop. So that's what the family had done for roughly 130 years. Everybody comes to me, literally every uncle, aunt I have on this planet, that's what the family profession is. And I was kind of the black sheep and broke ranks. 9/11 happened, decided I wanted to go to military, went to West Point, graduated West Point, kind of hit the war in Afghanistan in stride, deployed a number of times and was introduced to a very specific mapping technique on the battlefield that was used to scale our operational capacity during night raids. When I came home, my wife's a school teacher, so I wanted to take what I learned overseas and I initially applied it to her school. And very quickly found out that the school floor plans were both inaccurate and they were not compatible with the systems used by public safety professionals at the local, county, and state and federal level, and then kind of set down a path to solve that issue. Today, our company has mapped over 14,000 public schools across the country. There are 12 states that have made the mapping technique I'll introduce you to mandatory. And although we morally and ethically focus on mapping K-12 structures, we've mapped everything from the Super Bowl to Dallas and Reagan airports. But ultimately, where this technique comes from, as mentioned, born on the battlefield. The quick story is around 2005, 2006, U.S. military special operations is told increase our ability to conduct night operations with no additional resources. And as we started to really study that problem set, we realized the challenge we were facing on a nightly basis is we were often going to locations that we are not familiar with, which made it difficult for us to plan and communicate in an efficient manner when going to an operation, which is a very similar problem set facing first responders across the country when they respond to a critical incident at a place of worship or a school or a movie theater. Most likely it's the first time that they've ever stepped through that front door, making it very difficult to communicate and navigate efficiently. So the way that the military solved that problem was the implementation of a very simple mapping technique called a gridded reference graphic, or a GRG, because the military loves its acronyms. And ultimately, this concept of a GRG was super simple. It was a piece of aerial imagery of that location. Every single building was labeled, every single intersection was labeled, and it was gridded out like a game of Battleship. But what was most important is that everyone was forced to operate off that same piece of content, that same exact map. And when we were on the same map, we could actually work together and communicate efficiently, independent of what organization we were coming from. It didn't matter if we had a bunch of Rangers working with a bunch of SEALs. We were literally on the same piece of paper, so we could operate efficiently. In 2008, that mapping technique became mandatory in order to get approval to conduct a night operation. And in 2011, it's the mapping technique that was used to plan and execute the Bin Laden operation. And I show that only because, in my opinion, it validates the importance of this very simple technique. If you think about the importance and ultimately the resources that our country put forth for the Bin Laden operation, everything was on the table. You think about SEAL Team 6, President of the United States, literally everything is at their fingertips, and this is how they did it. I was fortunate, as was the co-founding team. We come out of this community. We knew the maps to be best practice. But as we came home, what we're introduced to for every piece of critical infrastructure in the country today is an emergency action plan that looks like the binder on the left-hand side. That is what the emergency action plan looks like for every K-12 school, every hospital, every airport. And in that plan today are often the blueprints or building schematics, which is our starting point. And what we wanted to do is take what's in place today and then help it evolve using some understanding of what we were doing overseas, and then also the understanding of the problems that responders are dealing with domestically, and take that old school floor plan and help it evolve into something usable. But along that journey, we identified 3 issues. First is that when you look at imagery, imagery is always presented in true north, meaning north is facing up. So as I look at Google Earth, Bing mapping, you know the imagery sources way better than I do. It is presented to that end user in true north. That's how they've standardized that presentation. But if you can see this gold star on top of this small elementary school, as I come from the imagery that's true north, and the gold star is on top of the library, and now I look at the floor plan for that location, you'll see the floor plan rotates and the gold stars don't match physical location. Reason being is that although imagery is standardized in presentation to the end user, floor plans are not. Floor plans are designed in what's called Project or Plan North, which is arbitrary. So if we talk about just the DC school system, every single school floor plan is rotated today in a different cardinal direction. The second issue is, if we, again, just focusing on K-12, the schools in the country, the buildings on average are 50 years old. That's 50 years of changes, renovations, and additions, and unfortunately none of those floor plans are accurate today. Of the 14,000 plus public schools we've done across the country, I have yet to find a single accurate floor plan anywhere in the country. This school is only a couple of years old, but on the top right, where you see the basketball court, that's actually the cafeteria. But no one, thank you, but no one took the time to actually update the floor plan that was on file with public safety. Excuse me. The third issue is the floor plans are rarely labeled in the nomenclature of the structure, meaning if you looked at that floor plan and I said go to the teacher's lounge, the art room, or door 7, that label is not overlaid on top of the floor plan. But unfortunately, when someone calls 911, he or she is going to pick up a phone and say, I'm having a heart attack in the teacher's lounge. But unfortunately, if that building has not been mapped appropriately, the individual who receives that call for help and the responding officer do not have an accurate representation of that structure at their fingertips. So what we want to do is address those 3 issues. Rotate the floor plans to true north to match the imagery, update the floor plans so they're accurate, and then label them to match the structure. I'm going to show a quick animation. What we do is we take whatever's on file, cut it out, rotate it to true north on top of an up-to-date piece of aerial imagery. We then walk every single structure with engineering software and we correct the base schematic. So if that facility has moved walls, moved doors, or changed at all, as we're going through that location with a human being, we're verifying the accuracy of the structure and the floor plans. After we now have an accurate floor plan, the next thing we do is we gather the labels associated with the structure. Is it door 1 or door A, classroom 3 or the art room, all plain text. Also, just as important as the interior, we also do the exterior labels of the structure. Is it parking lot 1, the student parking lot, the staff parking lot, the teacher parking lot? Again, how do they refer to that? So during an emergency, we've really leveled the bubbles and everyone's speaking the same language. Next thing that we do while on site is we gather the site-specific critical infrastructure pieces. So we find the fire access control panel, the gas shutoff, the electrical disconnects, things responders need during an emergency. We locate them. And then lastly, we grid it out. And the intent behind gridding it out is to make the maps super simple to use. So it doesn't matter if you're a public safety professional, an educator, an administrator. It doesn't matter your public safety discipline, police, fire, medical, emergency management, communication. This very simple graphic enables us all to speak the same language. So on this example, if I asked everyone to play a game of Battleship with me and find grid square J4, you would just find J or Juliet, top right margin, 4 left-hand side, like a game of Battleship. You bring them together, brings you to the northeastern portion of the structure. Inside grid square J4, there's a door marked door D, door Delta. So if I said, please find me at door D, come through that door, make your first right, meet me in Media Center. Chances are you've never seen this technique before. I doubt anyone's ever been to Brielle Elementary School in central New Jersey. But in about 10 seconds, I narrated and helped you navigate to a specific location. But these are not just simple static PDFs. They're very smart pieces of geospatial intelligence. I show this example as we call it a macro, a high altitude perspective of the campus. But the reason I show this is it enables me to talk about the tech stack we've built. We are able to pull imagery from any collection platform, satellite, drone, anything that we've collected or is given to us, and we can exploit that and stitch that together like kind of a jigsaw puzzle. Pull out the bad imagery, put the good imagery in. We also do it, when we do that process, we embed a lat long in each pixel in the imagery. So now that I have a very smart piece of imagery, I then overlay the floor plans accurately, and the floor plans now retain those geospatial properties. So because I had on the imagery where door 2 is, when I overlay the floor plan to scale, I now know that real-time location. So the problem facing the country today and the work that we're working to do, on the far left-hand side of the slide, that is what the critical infrastructure floor plans look like. If we talk, just the state of Virginia, we've mapped every school in the state of Virginia. When we started that process, the floor plans all look like the far left-hand side of the slide. So it's an absolute scavenger hunt, building by building, floor by floor, to find the raw content. After we find it, we have to fix it. So find it, fix it, lastly, disseminate it, which is the last and ultimately one of the biggest reasons we have a strong relationship with GeoSolutions. We had to find a way to make sure that once we completed that data, we had to export it in the multiple file formats that are relied upon in the space today. And what we've realized is, as important it is to have a common operating picture, unfortunately, there's just multiple different technical platforms deployed throughout the world. So our opinion is that in order to create a common operating picture, content is the key. We just have to be able to export that content and integrate it directly into the systems that is used by public safety, and we do that through a very robust partner network. So when we ultimately go and map a structure, let's say DC School District, we then work with the police department, the school, county sheriffs, 911, any piece of tech that they have deployed, the mapping content lives natively in that environment. So it's not an additional requirement for them to go buy additional software, it goes directly in their tool. And ultimately, that's one of the big things we do with GeoSolutions is upload our content into the cloud. There's two different versions two different ways we do it. I have an S3 bucket. An end user can just pull that content down and manipulate the way they want, or they can stream it in based on their capabilities. I do appreciate the opportunity to speak today. Thank you.
Thank you, Mike. Thank you for your important work in campus security, and GeoSolutions is honored to be supporting you guys in that effort. Next up, we have Karen Townsend with Sea Island Software, excuse me.
Your GeoSolutions. I'm Sea Island Software. Thank you. It's great to hear about this diverse set of applications, and I'm going to talk to you about hurricane tracking. HurEvac is short for Hurricane Evacuation. It's a storm tracking and decision support tool for government emergency management and managers. It has basically 3 main inputs. It has the forecast tracks that come from the National Hurricane Center, from the Central Pacific Hurricane Center, and because this is a worldwide tracking tool, also from the Joint Typhoon Warning Center, which is a division of the Navy. Next up, it has storm surge modeling information in the form of a SLOSH model, the Sea, Lake, and Overland Surge from Hurricanes model. And then finally, there is a piece that comes from the U.S. Army Corps of Engineers generated studies called Hurricane Evacuation Studies that look at the vulnerable area of the coastline, specifically and mostly to storm surge, what the roadway system and the population that are in those areas is, and arrive at how long it would take to evacuate the vulnerable area of the community. So the main goal of HurEvac is to assist the emergency manager in making evacuation decisions based on the timing and the potential severity of storm effects, such as wind and storm surge. So for the wind analysis piece, we use wind not only to assess the severity of the winds, but also the timing. The timing is very important when you're trying to fine-tune your decision-making. So this graphic is a storm that's still well off to the east, and so the center location of the storm at the time of this advisory is down in the bottom right corner of the map. And there's a few different layers that have been added to the map in HurEvac at this point. One is the overall chance of tropical storm force winds so it's a probabilistic data set that's represented by the different colors. The area that's at least contained within the green represents an area that has at least a 3% chance, or I'm sorry, a 5% chance of tropical storm force winds. You might think, why tropical storm force winds? Why are we focused on that and not the chance of hurricane strength winds? That's certainly a layer you can turn on. But the tropical storm force winds are the ones that the emergency managers are trained to focus on in terms of timing. You want to have your preparations completed ahead of the arrival of the tropical storm force winds, and HurEvac will help you determine what that time period is. That's also depicted in the lines that you see in this graphic that indicate the most reasonable time that those winds would begin in your location. For the storm surge piece, as I mentioned, uses the National Hurricane Center's SLOSH model. And there is an explorer in HURAVAC that allows you to combine lots of different model outputs and look at scenarios of storm, different forward speeds of storm, different wind field sizes, intensities of storm, and so forth. So you can do a lot of modeling even outside of a specific hurricane event by using the SLOSH Explorer. Second, HURAVAC has a lot of operational storm surge products. So for a specific advisory of a storm that's approaching your area, what is the probabilistic forecast of the reasonable worst case scenario for inundation of water above ground level? And that's done in the form of potential storm surge flooding. There's also watches and warnings surrounding storm surge, and there's peak storm surge graphics and even hindcasts after the storm has left. And then finally, the evacuation tool piece. This is where the hurricane evacuation studies come into play. There are evacuation zones that the coastal counties from Texas all the way up to Maine have drawn that indicate the areas that they would like to evacuate under different storm scenarios. For each of those storm scenarios, there is a specific number of hours that it takes to get the vulnerable population out. And so that information is already stored in HURAVAC and ready for the emergency manager to use in a live storm situation. The emergency manager can also input custom timeline actions, so other things that they need to do in advance of the storm, and generate lots of reports and graphical timing arcs. Finally, I would be remiss if I didn't mention HURAVAC's emphasis on inland flooding, even though it's not part of the timing component. Certainly ever since Hurricane Floyd made such a mess of the pig farms in North Carolina, there's been a focus, emphasis to put this information into HURAVAC. So how is evacuation start time calculated in HURAVAC? We take the storm forecast. We estimate the arrival time of the tropical storm force winds. In this example, that would be 8 p.m. on Saturday. From the hurricane evacuation study, a specific storm scenario is selected, which is a Category 3 storm. For that scenario in the area of the coastline that needs to be evacuated, the clearance time is 36 hours. So that means you want to subtract 36 hours from the start time of the hazards, and you arrive at an evacuation start time of 8 a.m. on Friday. So HURAVAC helps you fine-tune when you need to make your evacuation decision, when you need to start your evacuation, if you're going to have enough time to complete it. Okay, so what is HURAVAC's connection to open source? HURAVAC has been around since 1988. And it was first started by my father-in-law as a DOS-based program. He had a dial-up bulletin board system for people to quickly get on his bulletin board, grab the latest forecast. The latest forecast information is constantly being updated about every 6 hours. There's a new advisory that comes out for a system that's being tracked. So we have found that about every 10 years, the program needs to be completely overhauled with a new technology platform. And the latest platform, the current one that's web-based, began in 2017 with a DHS science and technology prototype. And it consisted of entirely open systems that you see described here. So how has the cloud-hosted open source experience compared to our former Windows desktop version? I thought that might be of interest to some of you who are developers in the audience. I came into the program in 2001, so I started with the Windows 95 version, and then we moved on to .NET. I will say that with the latest version, it's such a relief to not burden the end users and the local network administrators with installation of software. So that's great. There's also much better flexibility for us as developers to deploy bug fixes and enhancements on the fly. When the program was switched over to a web-based system, a lot of the users were concerned about it being so web-based versus the desktop program that just had to check for new data every 6 hours, and then everything was offline. But those fears have not really been realized, fortunately. I think our internet's availability has gotten much better over the years, and we're able to handle it fine. The thing I put in red, the good, bad, and the ugly, is that it is more expensive. So we found that the combination of hosting in the cloud and also the greater complexity of the system with all of these open system parts is more expensive. Okay, and then finally, what makes HERVAC a 35-year success? Free cost. It's thanks to FEMA, who funds the program. It's free of cost, and I would encourage you all to try it out. No GIS experience is necessary. A lot of these local emergency managers don't have that experience, so we want to make the program easy for them to understand. It's carefully curated in terms of its buttons, having certain look and certain functionality. The legends are custom, there's extensive help documentation, and so on. And then finally, we have really close collaboration with the National Hurricane Center in telling us how to curate that data, how to communicate that data, and that's been really valuable over the years. All right, so I'll end with this slide. You're welcome to contact me if you have questions. You can register for the program with this URL, and then we also run a webinar week every June, and that is coming up soon. So over 30,000 or almost 30,000 users for HERVAC. It's a free program. We'd encourage you to check it out. All right, thank you.
Thank you, Karen. There's also a pre-recorded video, which I believe will be on Project Geospatial, that goes into a deeper dive on HERVAC. If you're interested, you'll be able to find it there. So that leaves us to questions and answers from the audience. If anybody has any questions, otherwise we'll kind of open up a panel discussion with some questions.
I had a question for Mike Rogers. What plan do you have to maintain the files that you created so it doesn't end up in the same original out-of-date state?
I can't see who's speaking. I'm sorry. Can you raise your hand? Oh, okay, great. Sorry. Can you repeat the question? I'm sorry.
Oh, what plan do you have in place to maintain your files?
Great question. So we update the maps at a minimum every year, but if there's a change to the structure, we update at that moment in time. So they have to reach back out to us and say that they've changed. A good example would be the Javits Center in New York City. So as they go from the car show to the flower show, we change when they change. So on weekly in that case.
Thank you all. Karen, one question. What was the motivation for going global? I used to work at USAID and used to have to struggle trying to parse the Joint Typhoon Warning Center advisories, and it was like a gift from heaven when suddenly the whole world showed up on there.
Wonderful. Yeah. The reason to have HERVAC be a global program is because of Guam and American Samoa and Puerto Rico. It's important to support the territories. USAID has used our program some. There's a little bit of foreign slosh modeling going on. So Hispaniola and the Yucatan Peninsula have been modeled and are in HERVAC. However, with the current funding setup and the instructions from the National Hurricane Program that runs HERVAC, we are supposed to keep it restricted to government emergency managers and other government employees, but U.S.-based. So we're supposed to be U.S.-based for now. But I agree with you that the Joint Typhoon Warning Center's data stream is pretty difficult to work with.
Dr. Schuch, have you considered AI for some of the things to ease the burden on users that aren't familiar with GIS in terms of accessing the data and finding it?
So we are looking into AI as a park district. Right now, one of the things we're concerned about is kind of misinformation getting out there and staff using AI from different sources, but it is definitely kind of in our kind of list of things to look at. Yeah, thank you.
Hi, Karen. I've used HERVAC for years, and it's a phenomenal model. But I noticed in the presentation you talked about you guys have hindsight surge now. Have you guys looked into doing, hindsight inland flooding? I know with everything that happened in Floyd, I grew up in North Carolina. I went through all that, same thing in Florence. But looking at, I know the National Weather Service and NOAA does maintain some of that, but have you guys looked at doing the hindsight inland flooding as well to add into addition the hindsight surge so that local emergency managers can further plan evacuations for areas that have really seen strong inland flooding, especially enhanced by the surge?
Yeah, we are really focused on the plans that the National Water Center is putting into place. They're rolling out different sections of the country. I think that's mostly a forecast and forward-looking product. So for hindcasting and current flood inundation, we don't have too much right now. And HURAVAC is a program, is a tool for showing data sources that come from elsewhere, and would love to have you write to us and suggest this as a layer to add if you see something that specifically would be useful to have in the program. Thanks.
I have a question for Aaron. Aaron, what are your plans to get to a predictive state with Eagle Eye?
There are the models at Argonne National Lab called Headout that's doing outage predictions. We're looking a little more on the restoration side. So projects looking at both agent-based modeling for restoration, but also just looking at critical infrastructure impacts that could give us a sense of scale so we can kind of rank. And then also we're looking at the historic Eagle Eye outage data to understand normal behaviors so we can then look at through the history and kind of see how utilities and counties have improved on their ability to weather a storm and also respond and restore from it.
I have another question for Aaron. Did you have any issues with the utility companies not wanting to share any of their data with you?
We get blocked a lot from them, but we have a really good relationship with the Department of Energy and their industry committees that allow us to actually reach out to them and have good conversations about how we're using the data. And we're also very aware of when we present this work in public, we're not trying to say one utility is better or anything. So we're really conscientious about how we present the data and do those things. But so far, and even with Odin reaching out through the vendors and working with utilities, they're very interested in sharing the data. I think they want to understand what's the benefit back to them from doing it. And so some of the things we're doing with drones and other things, we're hoping will be that thing that would entice them to share even better data, higher resolution, more attribution that can allow us to really understand what caused the outage and kind of how the restoration times from their perspectives might look. So it's really been a good collaboration so far.
All right, thank you, Aaron. And thank you to our first round of panelists, Aaron, Karen, Mike, and Laura. And you'll be able to hunt us down throughout the day during the social. Please feel free to find us. And there are, additional information resources on each of their applications. If you come to the Geo Solutions table, we can connect you to them as well. Thank you.